In this video, we'll be determining the hybridization state of each carbon atom in the following compounds. For a review of the concept of hybridization states, check out the video titled Identifying Hybridization States Theory. So for our first compound, we have this molecule. So we want to determine the hybridization state of each of the four compounds, each of the four carbons in this compound. So let's number them from left to right: 1, 2, 3, and 4. So here's carbon 1, 2, 3, and 4. So now let's briefly go over the rules for determining hybridization states. To determine the hybridization state, we need to know either the steric number of the atom or the electron pair arrangement of the atom, for which we need the electron pair number to determine. So let's make a chart. So we have our chart right here. And so if we have a steric number of 2, then we have an electron pair number of 2. And then our electron pair arrangement is going to be linear. And our hybridization state is therefore going to be sp hybridized. Now, if we have a steric number of 3, our electron pair number is going to be 3. And our electron pair arrangement is therefore going to be trigonoplanar. So, trigonoplanar. And that's going to give us a hybridization state of sp2 hybridized. Now, if we have a steric number of 4, our electron pair number is also going to be 4. And that's going to give us a tetrahedral electron pair arrangement. Tetrahedral. And therefore, our hybridization state is going to be sp3 hybridized. And if we have a steric number of 5, our electron pair number is also going to be 5. And therefore, our electron pair arrangement is going to be trigonal bipyramidal. So, trigonal bipyramidal. Pyramidal. And we're going to have a hybridization state of sp3d hybridized. And finally, if our steric number is 6, our electron pair number is also going to be 6. And our electron pair arrangement It's going to be octahedral. And that will give us a sp3d2 hybridization state. And so mostly we're going to be dealing with the first three hybridization states, sp, sp2, and sp3. These examples will not be dealing with sp3d and sp3d2 hybridization states. So it's a good idea to keep this chart handy in the future. So if you remember, double and triple bonds count as single bonds or one electron pair. And so because covalent bonds are a sharing of electrons between two atoms, we say that there is one electron pair in a single bond. So for carbon 1, we have 4 electron pairs because we have 4 single bonds. 1, 2, 3, 4, giving us a steric number of 4. And if you remember, the steric number is equal to the number of sigma bonds plus the number of lone pairs. Since every single bond is a sigma bond, the steric number is going to be equal to 4 plus 0, which is 4, because there are no lone pairs in carbon 1. On the other hand, pi bonds usually only occur in double and triple bonds. So for carbon 1, we have a sigma, actually we have a steric number of 4. Our electron pair number is also going to be equal to 4. So our electron pair arrangement is going to be equal. It's going to be tetrahedral. And then finally, that will give us a hybridization state of sp3 hybridized. Okay, so that's going to be carbon 1. For carbon 2, since there are 2 single bonds and 1 double bond, and since double bonds count as single bonds in our system, we say that there are 3 electron pairs. And that gives us a steric number of 3, because 3 plus 0 is equal to 3, right? 1, 2, 3 sigma bonds for carbon number 2. Because if you remember, double and triple bonds contain only 1 sigma bond, and also there's no lone pairs. Therefore, our electron pair arrangement is going to be trigonoplanar, and our hybridization state is going to be sp2 hybridized. And that's going to be carbon 2. For carbon 3 and 4, we have two single bonds and 1 double bond. So just like carbon 2, we will have a steric number of 3, a trigonoplanar electron pair arrangement, and a sp2 hybridization state. So that's going to be the hybridization states of each of the 4 carbon atoms in this compound. So let's move on to another compound. So for this compound, we have this. We have a carbon, hydrogen, hydrogen, hydrogen. So here's our molecule, and let's label the carbons from 1 to 5, left to right. So we have carbon 1, carbon 2, carbon 3, carbon 4, and then carbon 5. So let's start with carbon 1. So for carbon 1, because we have 4 single bonds, right? 1, 2, 3, 4. We are going to have a electron pair number of 4, meaning we have a tetrahedral electron pair arrangement, making carbon 1 sp3 hybridized. For carbon 2, we have a single bond and a triple bond. Since there's only one sigma bond in a triple bond, the steric number is going to be 2 plus 0 equals 2, right? 1 sigma bond plus 1 sigma bond plus 0 lone pairs equals 2 plus 0, which is 2. Likewise, we count triple bonds as single bonds, so our electron pair number is going to be 2. So therefore our electron pair arrangement is going to be linear, and therefore carbon 2 is going to be sp hybridized. Since carbon 3 also has a single and triple bond, it's also going to be linear and sp hybridized. For carbon 4, there are 4 single bonds, just like carbon 1. So its steric number is going to be 4 because there are 4 single bonds, and all single bonds are sigma bonds. So 4 sigma bonds plus 0 lone pairs is equal to 4. So therefore, the electron pair arrangement for carbon 4 is going to be tetrahedral, and therefore it's going to be sp3 hybridized. And finally, for carbon 5 has the same bond structure as carbon 4, so it's also going to be tetrahedral and have a hybridization state of sp3. So now let's move on to our final molecule. So for our final molecule, we have a carbon double bond So this is our final molecule. So let's number our carbons from left to right. 1, carbon 2, carbon 3, and carbon 4. So for our first carbon, carbon 1, we have a double bond and we have 2 single bonds around this carbon. Since there's 1 electron pair per single bond and double bonds count as single bonds, we have therefore 3 electron pairs. Likewise, we have 3 sigma bonds and no lone pairs around carbon 1. So the steric number is going to be 3 for carbon 1. As a result, the electron pair arrangement is going to be trigonoplanar, and the carbon atom is going to be sp2 hybridized. For carbon 2, there are 2 double bonds surrounding it. 1 double bond here and 1 double bond here. Since double bonds have 1 sigma bond and 1 pi bond, the steric number is going to be 2 plus 0 equals 2. Likewise, since double and triple bonds count as single bonds, the electron pair number is going to be 2. And therefore the electron pair arrangement is going to be linear, right? Because it kind of looks like a straight line around carbon 2. And the atom is going to be sp hybridized. Carbon 3 has the same bond structure as carbon 2, so it's also going to be linear and sp hybridized. Carbon 4 has 2 single bonds and 1 double bond, just like carbon 1, and will therefore have a steric number of 3, since there are 3 sigma bonds, one for each single bond and 1 for the double bond, right? So 3 plus 0 equals 3. Likewise, it will have an electron pair number of 2, right? Actually make that an electron pair number of 3. So even though atoms with a complete octet have 8 electrons or 4 electron pairs, we count the double and triple bonds as single bonds with 1 electron pair, even though there are actually 2 and 3 electron pairs respectively. Therefore, just like carbon 1, it will have a trigonoplanar electron pair arrangement that will be sp2 hybridized. So that's going to be it for this video. With that being said, thank you for watching and have a great day.